Hello guys, I am Vaishali Kikan from Gill Learning Center and we are discussing the organic chemistry. So today we are going to start our discussion with the reduction reactions. So we are going to see the reduction of aldehydes, the reduction of ketones as well as the carboxylic acids. So for that we should have the reducing agents, right? So what are the various reducing agents? First is lithium aluminium hydride LiAlH4 and second is sodium borohydride NaBH4. So LiAlH4 is a stronger reducing agent, right? It is used to reduce carboxylic acid, aldehyde as well as ketones. It can reduce all three of them. Whereas if I talk about NaBH4, it's a weak reducing agent. It can reduce the aldehydes and ketones only, right? So it is easy to use, and this is the reason because LiAlH4 as well as NaBH4 both can reduce the aldehydes as well as ketone, but we prefer LiAlH4 because it is easy to use. Now coming to the aldehyde. So aldehyde in the presence of NaBH4 and methanol, it is going to reduce to form the primary alcohol. So for example, we have the ethanol CH3COO double bond OH, right? CH3C double bond OH. It is in the presence of NaBH4 and methanol, it is going to give me ethanol CH3CH2OH, right? So CH3CHO plus 2H is giving me CH3CH2OH. Now coming to the ketones. Ketones in the presence of NaBH4 and the methanol, it is giving me secondary alcohol, right? So for example, we have the propanol CH3C double bond O CH3. In the presence of NaBH4 and methanol, it is giving me CH3 CHOH CH3, that is the propane 2-ol. So propane 2-ol is formed over here. Coming to the next reaction, that is a carboxylic acid. Carboxylic acid in the presence of LiAlH4. Now here the strong reducing agent is used, CH3 CHOH CH3, that is the propane 2-ol is formed. Propane 1-ol will not be formed because the C double bond O is present over here at the center carbon in the ketone, right? Coming to the carboxylic acid. Carboxylic acid has to be reduced in the presence of strong reducing agent like LiAlH4. So carboxylic acid in the presence of LiAlH4 in the ethoxyethane and H plus or H2O gives the primary alcohol. So here let's suppose we have the ethanoic acid CH3C double bond OH in the presence of LiAlH4 in ethoxyethane and H plus H2O aqueous, it is giving me CH3C H2OH, right? That is my ethanol. CH3COH plus 4H gives CH3CH2OH plus H2O. This is the reaction. Coming to the reduction of nitrobenzene. This is my nitrobenzene. Benzene with NO2, it is reacted with 6 hydrogen in the presence of SN concentrated HCl and heat and NaOH, right? So these the reducing agents are required, and now it is going to form the phenylamine aniline. So this is the formation of aniline. So here we have the NH2 group present over the benzene plus H2O after the reduction of NO2 to NH2. So now we can represent this equation like this. The first equation will be when this reduction reaction will happen. So C6H5NO2, this is my nitrobenzene. The nitrobenzene will react with H positive plus 6H. It is going to give me C6H5NH3 positive plus 2H2O. Now this C6H5NH3 positive, this is the intermediate ion. This intermediate ion will react with OH negative to form C6H5NH2 plus H2O, right? So I hope you understood what are the various reduction reactions. Coming to the reaction pathway. So here we can understand the various reaction pathway. We have understood the various types of reactions, and the reaction pathway is the connection of all of the types of reactions that we have studied. So here we have CH2 double bond C CH3H. So here this is my alkene. Now alkene at the high temperature and pressure, when it is subjected to the oxygen gas, so it is going to form a polymer. So CH2 CH3H, and it is the unit which is repeated n times. So this is forming a polymer. Now in the presence of hydrogen, nickel catalyst and heat, so what will happen? The reduction will happen and this double bond will be removed, and here we will be having hydrogen. So CH3 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 C CH3H2. This is formed, right, by the reduction. So here double bond is reduced to form here the alkane, right? So now coming to this. Again here this can react with HBr in the presence of heat. So it is going to form CH3 C CH3HBr, right? So here we will be having the hydrogen going to the carbon which is having the more number of hydrogen atoms. So hydrogen will be going to this carbon and Br will be going to this carbon. Now coming to the second reaction, in the presence of Br2, so this double bond is replaced by 2 Br, so CH2, CH2, Br over here. So CH2Br, CH2Br is formed. In the presence of H2O, concentrated H2SO4 and heat, or H2O in gaseous form as a catalyst in high temperature and pressure, it is going to form the ethanol, right? So CH3, CH2OH, ethanol is formed. Now this ethanol can be reacted with NaBH4 and methanol at Cr2O7 or H positive or heat. So this ethanol can be oxidized to form. So here we have CH3, C double bond O, CH3. So this is the formation of the ketone. So propanol is formed over here. CH3, C double bond O, CH3, propanol is formed. So here the reactants that we are requiring is Cr2O7, H positive heat, NaBH4, methanol. So this is how we can form the given reaction. So here let's correct it. Here we have the CH3. Here also we have the CH3. So carbons are not increasing. So here we have CH3, C, CH3, H, OH. It is in the presence of oxidizing agent. It is going to form CH3, C, double bond O, CH3, right? So here it is oxidized, right? Now coming to this reaction. So when I have CH3, C, CH3H, Br. In the presence of NaOH, aqueous and heat, it is going to give me again CH3, C, CH3, OH. So there, here we are going to form the propane 2-ol, right? So alcohol is formed. Now coming to this reaction. So here this was my alkane in the presence of Br2 or UV light. First product it has formed was this. Now second product it has formed is the Br formed over here. So it has now not followed the Markovnikov's rule. So here this is the minor product. We have to consider this as well. So CH2Br, C, CH3H2, right? So in the presence of again NaOH and heat, we will be observing that again we are forming the alcohols. So propane 1-ol in the presence of Cr2O7, H positive and heat. So it is oxidized to form the aldehyde. So this aldehyde can again be reduced with the NaBH4 and methanol to form the propane 1-ol. So these reactions are, now we can go in any directions. These reactions can be moving in forward as well as reverse direction. Now this aldehyde in the presence of again oxidizing agent Cr2O7, 2 negative H positive, it is going to give me this ester, right? So here we have the CH3, C double bond O, O, C, CH3, C, CH3, right? So here H will be there. So now here what we have used, we have taken this, we have taken an alcohol, we have taken an aldehyde. So now here we can oxidize them, we can react. We heat this alcohol under reflux and we will be having the complete oxidation. And from here we can move back with the help of LiAlH4. LiAlH4 is a reducing agent in the presence of dry ether and H plus and H2O. It is going to give me again the alcohol. So coming back and moving front is easy in this reaction. So now here in the presence of this is my alcohol. So this is again my alcohol which is my propane 2-ol. This is my propane 1-ol. Propane 1-ol or propane 2-ol can be reacted now to form the ester, right? Again in the presence of some reacting agent. So you can remember the pathway like this. So we have to now consider which is the initial product, what are the reacting agents, and according to that we can find out what would be the result. So now let's discuss two questions based upon it. Design a reaction pathway for the formation of compound shown below. Use alkenes as the only organic starting material. So here we have to form an ester. So C, CH3, CH3H, O, C double bond O, CH3. So this is an ester which is formed from alcohol plus carboxylic acid that we know. So now here what would be the carboxylic acid? So if I cut it over here, right? So I will be getting C, CH3, CH3OH and C, CH3, C double bond OH. So CH3, C double bond OH is my ethanoic acid and this is my propane 2-ol. So now we have to form the ethanoic acid and propane 2-ol using the alkene. So for the propane 2-ol we have taken CH2 double bond CH, CH3. So when I am putting it in the H2 and concentrated H2SO4 and heat is provided, we are forming the propane 2 ol. CH3, CH, CH3, here at the second carbon we have OH. Now we are starting with the ethene to form the ethanoic acid. We are giving H2O concentrated H2SO4 and heat to form CH2, OH, CH3, right? So CH3, CH2, OH is formed. Now this is my ethanol. Ethanol is now again oxidized in the presence of Cr2O7 2 negative H positive and heat under the reflux to form the ethanoic acid. Now this ethanoic acid and propane 2 ol are passed through concentrated H2SO4 and heat to form this ester, right? So here let's understand the various reactions. So C2H4, this is the ethene that we have plus H2O is given in the presence of concentration H2SO4 plus heat is giving me CH3CH2OH. CH3CH2OH, when it is oxidized in the presence of 2 oxygen are coming from Cr2O7 2 negative H positive heat under the reflux. So we are forming CH3COH plus H2O. CH2CH CH3. This is the propene that we have. Propene in the presence of H2O, in the presence of concentrated H2SO4 and heat, it is giving me CH3CHOH CH3, propane 2 ol. So propane 2 ol will react with this CH3COOH ethanoic acid in the concentrated H2SO4 and heat, it is giving me CH3COOCH CH3 2 plus H2O. That is the product we had to form. Coming to the next question. Design a reaction sequence using the balanced chemical equation for conversion of propene to propanoic acid. So propene plus H2O will gives me propane 2 ol, right? We have already understood how propene, so here propene plus H2O gives me propane 2 ol. Why not propane 1 ol? Because it has to follow the Markovnikov's rule. Markovnikov's rule has been followed. So first of all, what I am going to do, I am going to convert the propene to propane, and then because here I need to make the propanoic acid, so I have to form the propane 1 ol. I don't have to form the propane 2 ol. So first of all, propene to propane conversion is done. CH3CH2 plus H2, it is reduced in the presence of nickel and heat to form CH3CH2CH3. Now this CH3CH2CH3 in the presence of Br2, in the presence of UV light, it is giving me CH3CH2CH2Br plus HBr, that is 1 bromopropane. 1 bromopropane is formed. Now this 1 bromopropane plus hydroxyl ion. So hydroxyl ion is coming from NaOH aqueous and heat, it is going to form CH3CH2CH2OH. Now we have formed propane 1 ol plus Br negative. This propane 1 ol will react with 2 oxygen. Now we are doing the oxidation in the presence of Cr2O7 2 negative or H positive and heat under the reflux. So we are forming CH3CH2COOH, that is the propanoic acid plus H2O. I hope you understood all of the things that I have discussed in this video. Thank you so much.